Hi everyone, Steven here, and today we're going to be doing a bit of a different video today from our usual user requests. And today we're going to be looking at a personal project I've been working on for the last little bit here. Now, it's kind of hard to explain what this project is, so I'll just explain it briefly and then show you how it runs. So I wanted to take a picture and recreate that in an Excel file, only using the cells of an Excel file. So I couldn't insert the image or anything like that. And I'll just open one of the images here to briefly show you how I thought of accomplishing that. So once we have the image here of Bart Simpson, I'm going to zoom in, and this is where I got the idea, is while zooming in a picture like this. And that's when I noticed that the pixels could theoretically be transposed onto a Excel file, because if you just resize a cell, it could kind of look like a perfect box, and then theoretically we could recreate the whole thing, just filling each cell in with a different background color. So that's where I got the idea from. And usually we would go over the code first, but I'm just going to run it and show you what it looks like. And I'll just reopen that image, not sure why I closed it, just so we can compare once it's done. And it's done. And here we go. So originally when you open it, it's very pixelated, but once you zoom out a bit here, you can kind of see it resembles the original picture. So I thought this was really cool. And we'll just do one more example of this just to show you how detailed it can get. And we're going to insert a picture of the Mona Lisa here. And I'll open it up for comparison while it's running. And click run. While that's running, this one right here. So this is what it's going to look like in the Excel file. And we'll just have to give it a few minutes because this one's a bit more higher resolution than the Bart picture. So it's going to take a bit longer. And there we go. The script is finished running. And again, it looks very pixelated once you're in it. And just to prove this, I probably should have this on the first photo. All of these are just regular Excel cells. So I'm going to zoom out again. And there you have it. It looks kind of like the original photo. So I thought this was a bit of a fun project, so that's why I did it. And for those interested, I'll go over the code right now. This, just a spoiler, this will probably segue into another project I have planned if I don't get a ton of user requests. So yeah. So first up, the libraries we're using are Pillow, and don't quote me on the pronunciation of that. And that's going to be reading our image into Python. And then we have something called XLX Writer. And what sets this apart from the other Excel Python libraries is that it can only create and write to Excel files, so it cannot read them. But that works for our purpose, so that's the library I chose to use. Okay, so going over the lines of code here, this one right here just opens the image and stores it in a Python variable. Next, we have a custom function called find size, and we pass in this variable and set it to the variable. Now, there is a reason for this custom function, and I'll scroll on down here. And that reason is when I first made the script, the Bart picture worked with no problem and no limitations. But once I started putting the Mona Lisa picture in, it started giving me some errors. And I couldn't figure out why exactly. And after a bit of trial and error, I realized that there's a certain number of cells that can have unique formatting. And according to the Microsoft documentation, which would have saved me a lot of time, that number is 65,490, although in my testing, I could only really get 65,475 cells before the Excel file basically became corrupted and it tried to repair it and deleted everything in the process. So this is what the method here does, is it takes an image and makes sure it can be printed in Excel first. So we'll just go over it quickly. So the first line here gets the width and height of an image. So in the case of the Mona Lisa, if I just go over to that picture file, and go show more options, properties, and go to details, and go to the width and height, you can see it's 2,196 by 2,860 pixels. So if you times those two numbers together, you would get the total number of pixels, which might not add up to the 65,000 just because some cells might have the same formatting. And we'll go into that a bit later. So with that being done, that's what that line does. And then this one just loads the pixels into a variable using image.load. And these will actually be the RGB values of the pixel. And RGB stands for red, green, and blue. So that's what gives you the color of the Excel background. And I'm just going to briefly explain that here in case anyone's confused. It's already open. So if I zoom back in on this photo here and go back over, click on any cell and go right click and then go to Format Cells. Might take a minute to open here. And then go to Fill and then go to More Colors. You can see that there's a color model of RGB and then there's values for all these colors, red, green, and blue. And then you can then translate this into a hex format, which is what we're pulling here. Or sorry, we're pulling the red, green, and blue values of 72, 25, 17, and then I convert it to a hexadecimal format like so. So yeah, that's what we're doing with those lines, is the pixels image is going to have every single pixel with its RGB values. Next, we create a dictionary with no entries, and the purpose of this dictionary is to keep track of all the unique cell formattings we're going to get from an image. And then these two nested for loops are basically just going through the whole photo, grabbing each pixel, and then cPixel is an individual pixel with the X and Y coordinate of the photo. And then I just add that as a key into the dictionary to keep track of that particular formatting. Next, it just prints out the width, height, and the length of the dictionary. And this will be a recursive function. So this is just mainly for the user to see how compressed the photo is going to get. And then what I do is if the length of the dictionary is greater than the limit I found while testing, then the image is going to be resized by half. And I did try various methods to do this, like reducing each width and height by about 1%, but I found just dividing it by half gave the best result after meeting less loss in resolution. And then finally, we're going to recursively call the function right here, and we're just going to pass in the new image attribute, and that's going to do it until it finally does not meet this threshold here, and then it's just going to return the image object. So that's the purpose of the function, is just to make sure our photo will meet the constraints of Excel. Okay, and then after that, what we're going to do is we're going to store that into I, and then we're going to open or create a new workbook called Picture SX, sorry. And then we're going to create a new worksheet, and we're just going to use that by adding worksheet. This will create the default sheet 1 name, so we won't do anything else with it. If you really wanted to, you could put a string in here with the sheet name, but I'm not going to. Similarly, we're going to get the width, the height of the photo, and then the pixels RGB values. So this, again, is just going to go over the picture, these two nested for loops. I'll just go quickly over these two lines right here. The purpose of them is to make the cell square. I don't know if you noticed, but when you open an Excel file, it doesn't give you a perfect cell square. It's usually like a rectangle. And so what we're doing here is we're just setting the column pixel length, I believe, to 20 pixels. And we do something similar right here where the row pixel height is 20. So we're just setting it to a 20 by 20 pixel block for this photo, just to give it that nice clean look. Next, we're going to grab the individual pixel like before in the method, and then we're going to write to the worksheet using the XY coordinates of the photo, and then we're adding the formatting, and we're setting the color to the getHex function I created here. So what that's going to do is it's going to parse that red, green, and blue value and convert it to a hex number like we saw before, and then it's going to have a bunch of helper methods to accomplish this. So I believe actually once we pull it from the picture, the hexadecimal is in the form of 0x and then the number. So we want to get that into the pound sign and then the number. So this just splits away the 0x. And then this one adds a leading 0 if the hexadecimal doesn't have the leading 0. And that's just for Excel because Excel won't accept it otherwise. And then that just combines the two. It strips the hexadecimal and adds the 0 and returns the results. So those are the helper functions. And yeah, and then we finally close the workbook and we're done. So this was a bit of a interesting project. I don't think it's what a lot of people think of, but I thought it was kind of interesting and I enjoyed making it. And it could possibly lead into a couple more videos if I get around to it. So yeah, thank you for watching. If you have a suggestion, please leave it in the comments and I'll try to get to it. Thank you and bye.